Assalamualaikum and good day. In this video, we are going to learn on binary eutectic phase diagram of limited solid solution. In previous video, we already learned on binary isomorphous phase diagram and also binary eutectic phase diagram of no solid solution. Before you begin watching this video, I hope you already understand on binary isomorphous phase diagram and binary eutectic phase diagram of no solid solution, because the 5-step technique for this diagram is also the same as other phase diagram. As a reminder, I will show you once again the 5 steps on solving for binary phase diagram. The first step is you need to find the phase or phases present. The second step is you need to find the composition of liquid and composition of solid. The third step is you need to find the wake fraction of liquid and wake fraction of solid at that location. The fourth step is drawing the microstructure at the selected point. The fifth step is drawing the cooling curve. All the steps are almost the same for all three binary phase diagrams. It's just for eutectic phase diagram, you have eutectic point. When you have eutectic point, you need to know about hypoeutectic and hypereutectic so that you can know the microstructure you should draw. Other than that, to find composition, you need to draw a line from the point until liquidus line to find composition of liquid, and line from the point until solidus line to find the composition of solid. When you use lever rule to find wake fraction, you need to draw the straight line from the point until solidus line to find wake fraction of liquid, and draw a straight line until liquidus line to find wake fraction of solid. I hope you clear on these 5 steps before we begin with this video. So, what is limited solid solution? It's written here, limited solid solution. The components are completely soluble in the liquid state, but limited solubility in the solid state. When we said it is limited solubility, it means that it has solubility limit. After that limit, the mixture will be separate and form two solid state phases. So, there are several different from no solid solution and limited solid solution. We can see from this diagram, for no solid solution, we have eutectic point is straight line like this, and we don't have this curve. This curve also is not available in no solid solution. We have this curve in limited solid solution because before this line we have complete solubility over here at the alpha area. Also, we have complete solubility at beta region over here. Other than that, at this alpha plus beta area, the component is separate and produce two solid phases. In this diagram, the two solid phases are denoted by alpha and beta. As a reminder once again, the y-axis showing you the temperature axis and x-axis showing you the composition, weight percentage of component B. For limited solid solution phase diagram, you can see there are three single phase region, which are alpha phase region, beta phase region, and liquid phase region. solver's line CF over here, CF denotes the solubility limit of B in A. Solver's line of DG, over here you can see DG shows the solubility limit of A in B. In this example, alpha and beta is used to denote for solid solution. Line AE and BE is liquidous line. This is line AE and this is line BE. This line is liquidous line. Above this line, all components are in liquid state only. Line AC, CD, BD are solidus line. You can see line AC over here, line CD and line BD over here denote as solidus line. Below this line, there is only solid phase or solid phases for this case, because at this area we have two solid phases, solid phase of alpha and solid phase of beta. They are not mixed together. Line CF and DG is solver's line. Line CF and DG is solver's line. Solver's line only available in limited solid solution only. You cannot find solver's line in no solid solution. Solver's line means that the line separate from completely soluble and separate solid state. For example, over here, when we mix A and B, it will form solid alpha. At this area, after the solver's line, for example, over here, we mix A and B, it will form separate phase of solid alpha and beta. After the DG solver's line, over here, for example, over here, when we mix A and B, they will form single solid phase. We denote it as beta. We take a look example of copper-silver phase diagram over here. For copper-silver phase diagram, you can see the liquidous line over here, and then solidus line over here. You can check my line. And then we have solver's line over here and also over here. Other than that, we have eutectic point over here. The eutectic point is fixed for copper-silver phase diagram at 71.9 composition of silver. You can check over here. And at temperature of 780 degrees Celsius. Determination of phase and phase composition for limited solid solution is the same as binary isomorphous system, where you can use the 5 steps that I have teach you. The first step, you need to find the phases present. I take example over here. The phase present is liquid only. I take over here, the phase present is liquid plus alpha. Over here, phase present is alpha only. Over here, phase present is alpha plus beta. Over here, we have liquid plus beta. And over here, we have beta only. So I hope you can answer if I ask what is the phase present over here. If you cannot answer this question, please repeat my other video for you to understand. The second step is to find the composition of liquid and composition of solid. Solid can be alpha or beta in this case. We take example at this point. To find the composition of liquid, you just need to draw a straight line at this point until the liquidus line, and then you draw down until you reach the composition. To find the composition of solid, just draw straight line from the point until solidus line, and then draw down until you find the composition of solid. So for this case, the composition of solid will be the composition of beta, because only beta is available in this region. I give you another example to find the composition. For example, at this point. At this point, you only have solid phases only, which are solid phase of alpha and solid phase of beta. So what you should do is draw a straight line until solver's line, this line, and then draw down so you can find the composition of alpha, because over here only have alpha, and then draw another line until this solver's line over here, and then you draw down until you find the composition of beta, because over here only have beta. I hope it is clear. At this point just now, there are no composition of liquid because only solid phases are present. So what is composition over here? At this point, you only have composition of alpha, so it is 100%. Composition of beta will be 0, and composition of liquid also 0. I hope you can answer if I ask composition over here at this point. For the third step, we need to find weight fraction of liquid and weight fraction of solid. Solid can be alpha or beta for this case. To find the weight fraction, you need to use lever rule. For example, to find the weight fraction at this point, the weight fraction of liquid, you need to calculate this length, denoted as Q over here, divided by overall length, denoted as R plus Q. To find weight fraction of liquid, we use this Q line because we use lever rule. To find weight fraction of liquid, the line we use is the line until meet solidus line. To find weight fraction of solid, we use R line, where the line is from the point until over here. The fourth step is microstructure. For microstructure, you need to know the microstructure from binary isomorphous phase diagram and binary eutectic phase diagram of no solid solution. For example, over here, the microstructure only liquid, and then you have the microstructure at eutectic point over here. It's just the same as you find from no solid solution, where you have grain boundaries and lamellar structure of eutectic alpha and eutectic beta. For microstructure on eutectic point, please watch my video on binary eutectic phase diagram of no solid solution. And then we have hypoeutectic and hyper-eutectic. For microstructure at this region and this region, please watch my video on binary eutectic phase diagram of no solid solution under hypoeutectic and hyper-eutectic microstructure. I already explained in detail in that video. Microstructure over here and microstructure for over here is the same as microstructure for solid phase of binary isomorphous phase diagram. Please watch my video on binary isomorphous phase diagram to find the microstructure of solid here and also over here. And lastly, for the fifth step is cooling curve. The cooling curve for limited solid solution is the same as cooling curve for no solid solution. You can divide the cooling curve into two sections. The first section is on eutectic, where you get the cooling curve that is the same as cooling curve of pure metal, and then you have cooling curve at hypo or hyper, which are the same cooling curve as hypo and hyper for no solid solution. Please check my video on cooling curve for binary eutectic phase diagram of no solid solution. How about the cooling curve over here? At this composition, the cooling curve is the same as the cooling curve at hypo or hyper-eutectic, where you have two temperatures. The first one is over here, then the second one is over here. But the difference is the cooling curve at this composition will be the same as cooling curve for solid phase on binary isomorphous phase diagram. It is because it did not go on eutectic temperature. Eutectic temperature will start at here until here only. When the cooling curve does not cross the eutectic temperature, there will be no constant temperature solidification. Once again, I told you for this temperature, please watch my video on binary isomorphous phase diagram for solid phase cooling curve. For cooling curve, there will be three different cooling curves that will be drawn. The first one is at eutectic point. The second one is at hypo or hyper-eutectic. And then the third one is at the complete solid over here and over here. At the eutectic area, you will get cooling curve in this shape, where you can find the constant temperature solidification, the same as pure metal solidification cooling curve. So at hypo or hyper component, you will get a cooling curve with this shape, where you have liquid temperature and eutectic temperature. So you have four lines. The first one is liquid. The second one is solidification process at various temperature. The third one is the straight line, is the solidification at constant temperature. And the fourth one over here is the cooling of the solid process. And then at this area and also this area, you will find the cooling curve like this. The cooling curve has the liquid temperature and also the solid temperature. So you will have the first line is liquid cooling line. The second line is solidification occurs at various temperature. And then the third line is the solid cooling down process. Once again, for clearer explanation, please watch my two other videos. So that's all from me on introduction of binary eutectic phase diagram of limited solid solution. Videos on example of solving binary eutectic phase diagram of limited solid solution will be given in the next video. I hope you enjoy learning from my video. With that, thank you. Have a nice day.